Okay, geometry, lesson 21. We're going to talk about two things today. It's a law of detachment and a law of syllogism. Let's make sure our headphones are out. Chromebooks are, well, I mean, you can pay attention up here, I guess, but let's make sure that I've got your attention. Basically what this is dealing with is deductive reasoning. A lot of it is still working along the lines of not necessarily if-then statements, but not too far off of that. For two of you at least, Michael and Katie, we've seen some of this in our Algebra 3 lessons, and even had some questions on tests that deal with this. So I'm going to take some cues from Algebra 3. Some things that it doesn't go over in the book that'll help you understand this, hopefully a little bit better. And if some of you end up taking Algebra 3, you'll already be familiar with this by the time you get there. So deductive reasoning is the process of using logic to draw conclusions from a given set of facts, definitions, and properties. So when two related statements are true, deductive reasoning can be used to make a conclusion. All right, deductive reasoning is, I think, outside terms, if you're familiar with, let's say, Sherlock Holmes, for instance, uses deductive reasoning. If this is true, then this is true, then this is true, right? Does that kind of make sense? We can deduce certain facts based upon given facts. Certain things that we know are true indicate that other things are probably true. So here we see a statement. The bakery makes fresh bread every morning. Okay, so what I want you to notice about this is that, and it doesn't go over this in your geometry lesson, but there's a minor premise and a major premise. Okay, whenever we see things like every or all, that's my major premise. That's the big overarching thing. Okay, and then the next part of the statement is going to be my minor premise. So if we have the bakery makes fresh bread every morning, it is morning, right? This is what I'm deducing, or this is the next given fact. This, therefore, is my deduction. Okay, what I'm deducing from the fact that it's morning. Because my given is my major premise, I can deduce the minor premise. Does that make sense? If they had said, the bakery makes fresh bread every morning, the bakery is making fresh bread, therefore it is morning, is it necessarily true? Why is that not necessarily true? Well, because would a bakery make fresh bread throughout the day? Yeah, right? So just because they're making fresh bread doesn't mean that it's morning, but if it is morning, they're going to be making fresh bread. Does that make sense? Okay, so if my given is associated with the major premise or the premise that's all or every, then I can deduce the minor. All right. So law of detachment breaks it down into an if P then Q. Well, that's our conditional statement, right? We're used to saying if P then Q, my hypothesis, my conclusion. All right, where my P is going to be my major premise, and my Q is going to be my minor premise. Okay. For two statements, if P and Q, when if P then Q is a true statement, and P is true, then Q is true. So if they give me this statement, I find out that my major premise P is true, then I know Q is true. The law of detachment is a form of deductive reasoning that can be used to draw valid concluding statements. When the given facts are true, then correct logic can lead to a valid conclusion. All right. So down here, right, we get an example. If it is Monday, then Mark will go to work. Okay, which part of that is my major premise? Just of this line right here, what part of this is major? Nope. Monday. Okay, like I said, the first part of an if-then statement, my hypothesis, should be my major statement. Monday. Okay? My minor premise, Mark will go to work. Look at it like this. Look at it in terms of dependent versus independent, right? Okay, so let's see. Today is Monday. Therefore, Mark will go to work today. Okay? Just because Mark is going to work doesn't mean that it's Monday, because could he go to work on other days of the week? But what do we know for a fact? That on Mondays he goes to work. Okay? Is it possible that he only works Mondays? Yeah. Okay? Our major premise is Monday, major, minor, Mark goes to work. Okay? So if major, Monday, therefore, Mark will go to work. Okay? If this statement is ever attached to the minor, I can't make it's not necessarily true. Okay? All right, in the statement above, P represents the phrase "it is Monday," which is the major premise, and Q represents the phrase "Mark will go to work," which is the minor premise. All right, so that's the law of detachment. If P, then Q. Okay, does that? So if we have an if P, then Q, okay, then we make a statement P is true, then Q is true. That's essentially the law of detachment. If P, then Q, P is true, then Q is true. Okay, I'm going to say that one more time. If P, then Q, if the first part is true, then the second part is true. But I can't say if the second part is true, then the first part is true. Okay, now we switch over to law of syllogism. Syllogism includes more parts. Syllogism works like the transitive property. I'm not sure if you're familiar. I mean, we've talked about the transitive property. The transitive property is basically if A equals B and B equals C, then A equals C. Right? Does that make sense? Okay. All right, so law of syllogism does that same thing. So if we have A, B, and C, then we're going to have three variables. If P, then Q, and if Q, then R are true statements, then if P, then R is a true statement. Essentially, if A equals B and B equals C, then A equals C. You got to stay with me, Jose. Okay. So the law of syllogism is another form of deductive reasoning. It basically throws in a third fact. In this case, a third conditional statement in which the conclusion of one of the hypothesis is the hypothesis of the other. The law poses that an intermediate truth is a valid progression from the original statement to a valid conclusion. For example, all right, and this is how we're going to break this up. If there's a power outage, okay, so power outage, let's call this A. The freezer does not work. Okay, let's call that B. Okay, we're seeing how to break this up. If the freezer does not work, okay, well, what is that? That's B. Then the ice cream will eventually melt. Okay, ice cream will eventually melt. What are we going to call that? C. Okay, so we basically said if A, then B. If B, then C. Then power outage is what? A, ice cream will melt, which is C. Okay? If A equals B and B equals C, then A will equal C. That shouldn't be too hard, but you do need to know the difference between detachment and syllogism. Those are two words that you might be unfamiliar with. Okay, so that would be the important parts in your notes, is understanding the difference between detachment and syllogism. So, from here, let's try to answer a couple questions. Determine if the conjecture is valid by the law of syllogism. Okay, remember, syllogism is A, B, C. If A, then B. If B, then C. Then we would have if A, then C, right? So, if you are in California, what is California? A. Then you are on the West Coast. On the West Coast is what? B. If you live in Los Angeles is what? C. California is A. West Coast is B, Los Angeles C. Then you are in California. California is what? A. So notice that they do if A, then B. If A, then C. So what do I have to connect in my last part? What? Well, I'm not going to say A equals A. I have to connect the two parts that are not yet connected, right? So notice that our conjecture is if you are in Los Angeles, well, Los Angeles is C, right? What has C not been connected to? Okay? C has not yet been connected. So we've got A equals B, and we've got C equals A. Down here we see C equals, and we need it connected to B, right? Well, what is B? West Coast. Is this, okay, so that's West Coast. Is this conjecture valid? Yeah, because we've connected the unconnected parts. Okay? Using the law of syllogism. Do we follow the logic here? Okay, if you don't understand it, you won't get the questions right. Okay, let's look at another one, another law of syllogism. So my biggest advice to you is underline the important part, give it a label. I don't care if it's A, B, and C or P, Q, and R. Okay, it doesn't matter. You could call it 1, 2, 3 for all I'm concerned. Okay, but you should underline it. If you write it down on a test or write it down in your homework, underline it, give it a label so that you can see the distinguishable parts. Okay, if two lines are perpendicular, what do I want to underline there? Okay, up to the comma. What do I want to underline to distinguish for myself? Perpendicular. What do you want to call it? A. Okay. If two lines are perpendicular, then they form right angles. What do you want to underline? Right angles. What do you want to call it? B. Okay. If two lines meet at a 90-degree angle, what do you want to underline? 90 degrees. What do you want to call it? C. Then they are perpendicular. What do I want to underline? What do I want to call it? A. If two lines meet at 90 degrees, what do I want to underline? What do I want to call it? C. All right. Then what? What's my conclusion? Because I'm looking at this last part. Two lines meet at 90 degrees. Well, what's already been connected? Okay. Because we have A equals B up here, we have C equals A in my next statement, and we have C equals, what does C need to equal? B, which is right angles. That's why that is the answer. It doesn't mean that the others are not necessarily true, but that's the one I want to connect it to. Do you see why it's important to underline the important parts, label them so I can see what I need to connect to what? Okay? All right, 3. This is law of detachment. Okay? Law of detachment. If Tommy made enchiladas tonight, then Tommy must have an oven. Okay? Which part of this is my major? Yes. Okay. My hypothesis is always my major. Enchiladas. Made enchiladas is my major. Okay. What's my minor? Has an oven. Okay. Minor. And the reason that the oven is the minor is because can I make other things in an oven? Yes. Okay. Tommy has an oven, therefore Tommy made enchiladas tonight. Is that valid? No, because my next statement is based upon the minor. I can't use a minor to prove a major. Okay? It's invalid. Okay, so we're looking for the not valid. B says not valid because if Tommy didn't have an oven, then he couldn't have made enchiladas. Is that true? Well, let's look at the other one. The conjecture is not valid because Tommy could have an oven, but he may not have made enchiladas tonight. Is that? Okay, so read both of them and see which one makes more sense. Don't ever just go with the first one that agrees with your, with your overarching theme, which is that it's not valid. Read them both and see which explanation makes the most sense. Okay? All right. 4, deductive reasoning to form a therefore concluding statement. All eligible maidens in the kingdom were united to the hall. Okay, what's my major? All eligible maidens, because we see the word all show up. It's not an if-then statement, but because we're using words like all or every, we see the major statement show up there. What's my minor statement? We're invited to the hall. That's my minor. Okay? Cinderella is an eligible maiden in the kingdom. Are we attaching my next statement to the major or the minor? The major, right? Because she's invited to, she's an eligible maiden. Okay? Therefore, what? What's my therefore statement? Therefore, she will be invited to the hall. Which should be ball, but whatever. Okay? Are you guys following? Because some of you look like you're bored out of your minds and you've completely tuned me out. Okay? Some of you can't afford to tune me out. As basic as this stuff seems, the stuff that you tune me out over is going to be the questions you get wrong on test, and it should be the easy stuff. Okay? I think, I don't know, this might be one of the last, I think there's like two or three questions. Do we feel like we understand this? No, not yet. All right, let's look at least number 5 before we finish. Okay? If a number is a perfect square, it is not prime. Okay? What's my major statement? Okay? Perfect square. A number is a perfect square is major. Okay? It is not prime. It's minor. Okay? 49 is a perfect square. Is that major or minor? Major. Therefore, what? Therefore, it is not prime. Good job. Okay? I think we can probably answer maybe one more. I want to see if either of these should be quick. If a triangle is obtuse, then it contains one obtuse angle. Okay? Obtuse, major. One obtuse angle, minor. Triangle FGH is obtuse, major. Therefore, it contains one obtuse angle. Very good. Now, last one is number 7. Okay, we've got if P, then Q, if Q, then R, if P, then R. Basically, wants you to write those 3 statements. So I'm going to say this verbally for you. You can go back and watch this. All right, if P, then Q. So we would say, if Peter goes to bed early, then Peter will be rested for his game. That's my first statement. Okay? Okay, if Q, then R. If Peter will be rested for his game, then Peter will play well. Does that make sense? Okay, then what's my if P, then R statement? Perfect. If Peter goes to bed early, then Peter will play well. Okay, we've answered all of them. We can stop right there.